Today in this class, we are going to study about the Gibbs free energy and work, right? So, as in the previous lessons, I have already told you that we can find out about this feasibility of the reaction and about the spontaneity about the reaction if we know about the entropy. Entropy is one of the entropy is one of the way you can calculate, you can find out about the feasibility, the change in entropy, you can find out about the feasibility of the reaction. If the entropy is a positive value, we know that the reaction is going to take place and it's going to be spontaneous. Now, Gibbs free energy is another factor, is another way to find out whether the reaction is going to be feasible and spontaneous or not. Gibbs free energy, we write it down with the symbol G, and if the value for Gibbs free energy is a negative value, then the reaction is going to be feasible or it's going to be spontaneous. So let's see what Gibbs free energy is. When we have the total energy change, when we talk about the total energy change can also be said as enthalpy change. So out of this total energy, whatever is there for a reaction, out of that, the Gibbs energy is an energy which is available to do the work, right? And the remaining part, which is not available for doing of the work, is the energy which is not available, and it's basically used for creating a disorder in the surrounding. So we can say that that is your entropy change, the change, either the energy which is utilized, which is used for work done as Gibbs, and apart from that, whatever the other whatever the other part of the energy that's used to create the disorder in the surrounding, that's delta S. So when you combine both of them, the Gibbs and T delta S, and you have the enthalpy change or a total energy change. So this particular relation, we can write it down in the form of that we can say that the Gibbs free energy is basically is when from the total energy you subtract T delta S. So that means the entropy taken place, take entropy or a disorder which is done at one specific temperature, because we know that delta H, which we call as a total energy, is a sum of Gibbs free energy and the energy which is not needed for the work done. That is basically the energy which is needed for, which is actually used up in order to produce a disorder. So when you add them up, you have delta H. And if you want to rearrange this particular relation to find out the Gibbs free energy, then this is going to be the way how you can calculate the Gibbs free energy, right? So we can say that in order to calculate the Gibbs free energy, we have a formula which is basically delta G. That's a Gibbs free energy change. You are getting it when you subtract T delta S, okay, at a specific temperature, whatever the entropy is, from the total energy change. You get the Gibbs energy change, right? So Gibbs free energy can be given by two relationships, right? You can give the two formula for that. So the first formula is delta G is equals to minus T delta S, where you're talking about the entropy, the total entropy, or you can write it down when you talk about only the entropy of the system, then that is basically delta H, enthalpy change of a reaction. From that, you subtract the entropy of the system at a given temperature. What you get, you will be getting the Gibbs free energy for that particular reaction. So Gibbs free energy is a topic which has been added in your syllabus. Gibbs free energy is a topic which has been added in your syllabus from 2016. So before 2016, this topic was not there in your syllabus. So you'll find out the past paper 2016 onwards, you'll find the questions on Gibbs free energy, right? Now, the kind of question which they normally ask is that they ask you to predict. Likewise, we have learned how to predict the entropy. So they will be giving you a reaction and they'll just ask you to predict that in this scenario, because its formula is delta G is equal to delta H minus T delta S. So if a reaction is given, and in that reaction they have given you the enthalpy change, whether it's an exo or it's an endothermic, and they have given you the entropy of the system, they can ask you, okay, what is going to be the value for delta G? Just predict it. So the first type of scenarios come in the past paper question is to predict that if you have an exothermic reaction, or the entropy change for a system is going to increase or decrease. So what is going to be the change in the Gibbs free energy? So depending on the scenario, you have to predict. So I'll teach you first how to predict the Gibbs free energy. If these two values, these two terms are mentioned, if they are given in the question, number one. Number two, they ask you to calculate. Now, if they ask you to calculate the Gibbs free energy, the change in the Gibbs free energy, then both the quantities delta H and T delta S are given to you, right? So using the same formula, you can again use you can calculate the Gibbs free energy there, right? Now, apart from that, the third category of questions which comes is, they ask you the Gibbs free energy change, the change in Gibbs free energy in a reaction. So that means they have given you the Gibbs free energy of the reactant, right? And they have given you the Gibbs free energy of the product, right? So if they have given you the values for, like, for example, if similar to that, if they ask you to calculate the enthalpy change of a reaction, what do? You subtract the enthalpy change of a product minus enthalpy change of a reactant. Similarly, if these two values are given to you, the Gibbs free energy of a reactant and the Gibbs free energy of the product, you can easily calculate the Gibbs free energy for a reaction by using the same formula. So delta G for a reaction will be nothing but whatever the Gibbs free energy for the product you have, you will be subtracting in from the Gibbs free energy given of the reactant. ठीक है, तो दोनों की वैल्यूज को जब आप सब्ट्रैक्ट करेंगे तो you will be getting the Gibbs free energy change for that reaction. So these are basically the three type of questions they normally ask, and then there is a general awareness you need to have, okay, what is going to be the Gibbs free energy at the equilibrium if the reaction is going to be irreversible. So we'll talk about it and a little more detail about it. So that is all about which is going to cover this today's video. Let's talk about the prediction first. So we are doing the first part of the Gibbs free energy where we are trying to predict whether the reaction is going to be feasible or it's going to be spontaneous or non-spontaneous, or feasible or non-feasible on the basis of Gibbs free energy. And we know that this is the formula for that. It's delta G equals to delta HR minus T delta S. And this is entropy for a reaction. And this is enthalpy for a reaction. So we are talking about whether this is going to be feasible or not feasible for the reaction. So let's consider this as one term. This is the term one, right? And let's consider this as term two. And let's make और यहाँ पर हम क्या करते हैं, different variety of combinations डालकर कभी हम इसको delta H को consider करेंगे as an exothermic, कभी endothermic, similarly entropy को positive or negative. So we will be having four possibilities और उनके हिसाब से हम predict करते हैं कि delta G की values किस तरह से effect होंगी. Okay. Now for example, let's talk about अगर हमारे पास reaction जो है वो exothermic है, that means मेरे delta H की value जो है वो negative है. ठीक है, and let's see कि अगर delta S की value for this particular reaction is going to be positive, तो entropy की वजह से तो system, entropy of a system तो कह रहा है कि okay positive है, तो entropy of a system अगर ये positive है तो minus T delta S overall क्या हो गया, considering this negative value, negative positive will become negative. So T delta S will be a negative value. So basically क्या हुआ, यहाँ पर आपकी negative value है और ये भी negative value है. So overall Gibbs will become what? Overall Gibbs is going to become a negative value because you are going to sum them up together. सही, तो Gibbs will be basically a negative value at all temperatures, चाहे कोई भी टेम्परेचर हो, चाहे आपका टेम्परेचर लो टेम्परेचर हो, चाहे हाई टेम्परेचर है, so temperature has no role to play here. तो at all the temperatures this is going to be a negative value, and we already know that Gibbs की value अगर negative होती है, if it is a negative value, then the reaction is considered to be a feasible one. Then the reaction is considered to be a feasible reaction. So in this scenario, we are getting a Gibbs negative energy, which is saying that अगर delta H की value negative, अगर reaction exothermic है और entropy जो है वो आपकी positive है, तो minus T delta S will be negative, and this value is going to give you Gibbs free energy negative at all temperatures. So we will predict that the reaction will be feasible. The reaction will be, it is going to be feasible at all temperature, at all temperature. तो no matter temperature आपका low है या temperature जिस पे रिएक्शन हो रहा है हाई है, हर टेम्परेचर पे गिव्स फ्री एनर्जी जो है वो आपकी नेगेटिव होगी और रिएक्शन फीजिबल होगा. ठीक है. नाउ लेट्स कम मूव ऑन टू द सेकंड सिनेरियो. व्हेन वी टॉक अबाउट द सेकंड सिनेरियो, वी अगेन हैव गॉट, let's look at these two terminologies here. अगर आपके पास यहाँ पर फिर से you have an exothermic reaction, अगर कॉम्बिनेशन में आपके पास डेल्टा एच की वैल्यू नेगेटिव है और एंट्रोपी जो है, नाउ लेट्स से द एंट्रोपी इज गोइंग टू बी योर नेगेटिव, आपकी एंट्रोपी नेगेटिव है. दैट मींस एंट्रोपी ऑफ रिएक्शन हमें बता रहा है आपका कि ये जो है नॉन फीजिबल है एंट्रोपी के हवाले से. तो अगर ये आपकी, इफ यू हैव दिस वैल्यू, दिस इज योर नेगेटिव वैल्यू and entropy is going to be your negative value too, right? So automatically, so this negative and this negative is going to convert this delta TS value to be basically your positive value. ठीक है, ये आपकी पॉजिटिव वैल्यू हो जाएगी. अगर आपकी ये पॉजिटिव वैल्यू हो गई यहाँ पर, ठीक है, इफ दिस इज अ पॉजिटिव वैल्यू देन यू विल बी हैविंग ओनली द नेगेटिव वैल्यू. आपका ये वैल्यू जो होगी ये कंपैरेटिवली हाई होगी. दिस नेगेटिव वैल्यू इज गोइंग टू बी हाई एट द लो टेम्परेचर. तो ये गिब्स फ्री एनर्जी जो होगी वो सिर्फ नेगेटिव होगी इफ योर टेम्परेचर इज लो. ठीक है, और नेगेटिव का मतलब है कि वो फीजिबल तब होगी जब व्हेन द टेम्परेचर इज गोइंग टू एट लो टेम्परेचर. अगर टेम्परेचर यहाँ पर हाई हो गया, अगर टेम्परेचर हाई हो गया तो पॉजिटिव वैल्यू जो होगी वो डेल्टा एच की नेगेटिव वैल्यू से बढ़ जाएगी. जब पॉजिटिव वैल्यू बढ़ जाएगी तो ऑटोमेटिकली गिब्स की वैल्यू जो होगी वो पॉजिटिव हो जाएगी, जिसकी वजह से रिएक्शन जो है वो नॉन फीजिबल हो जाएगा. So we will say that the reaction is going to be feasible. The reaction it will be feasible only at low temperature, right? So reaction will be feasible only at low temperature, only at low temperature. At the higher temperature पे आपकी term 2 जो है, this term 2 will be positive, which is going to make delta G positive, which is going to make the reaction non-feasible, right? So the second combination is clear. Now moving to the next particular part of it, right? Coming to the third combination, we have done both the exo. Now let's move on to the endothermic scenario. When you talk about the endothermic scenario, तो delta H की जो वैल्यू होगी वो होगी आपकी बेसिकली पॉजिटिव वैल्यू. अगर ये आपकी पॉजिटिव वैल्यू है तो अब हम यहाँ पर एंडोथर्मिक की जो वैल्यू है, लेट्स टेक इट फर्स्ट एज अ पॉजिटिव वैल्यू. जो एंडोथर्मिक एंट्रोपी के हवाले से हम इसको फीजिबल रिएक्शन ले रहे हैं और एंडोथर्मिक भी आपकी पॉजिटिव वैल्यू है. ठीक है, तो अब आप यहाँ पर देखिए, हैव अ लुक एट हियर. तो दिस इज बेसिकली योर पॉजिटिव वैल्यू. ठीक है, ये पॉजिटिव वैल्यू है और यहाँ पर भी आपकी पॉजिटिव ही वैल्यू आ रही है. तो प्लस माइनस प्लस, दिस इज गोइंग टू बी, तो प्लस माइनस is going to be a minus, so this is going to lead as positive and you will be having negative t delta s. ठीक है, ये वैल्यू आ जाएगी आपकी नेगेटिव t delta s. तो आपकी जो गिब्स होगी, अगर आपकी गिब्स है नेगेटिव वैल्यू, इफ यू वांट द गिब्स वैल्यू टू बी नेगेटिव, देन दिस टर्म शुड बी अ बिग टर्म. That means this here the temperature should be a higher temperature. ठीक है, अगर आपकी टर्म जो है, अगर ये वैल्यू अगर आपकी बड़ी है तब आपका डेल्टा गिब्स एनर्जी जो है वो नेगेटिव होगी। इसका मतलब एट अ हाई टेम्परेचर, टेम्परेचर आपका क्या होना चाहिए, यू नीड टू हैव अ हाई टेम्परेचर। अगर हाई टेम्परेचर होगा तो गिब्स जो होगा वो फीजिबल होगा। और एट द लो टेम्परेचर, अगर आपका लो टेम्परेचर है तो नेगेटिव छोटी वैल्यू होगी, जिसकी वजह से आपका गिब्स जो होगा वो पॉजिटिव हो जाएगा। ठीक है, सो वी नीड टू अंडरस्टैंड कि अगर आपकी ये पॉजिटिव वैल्यू है तो ओवरऑल आपकी टी नाइन डेल्टा वी इज गोइंग टू बी योर नेगेटिव वैल्यू। और अगर ये नेगेटिव वैल्यू है तो ओवरऑल दिस इज गोइंग टू बी नेगेटिव ओनली, इट्स गोइंग टू बी नेगेटिव at high temperature, at high temperature. So we'll say that the reaction is feasible, the reaction is spontaneous, or reaction is feasible at high temperature. Fine. At the low temperature, we are getting the Gibbs value, which is positive, which is making the reaction non-feasible, non-spontaneous. Coming to the next example, next combination. If again, the fourth combination, we have an endothermic reaction, and now let's have the entropy as a negative value. So if you're going to have the entropy as a negative value, let's see what will happen then. So if we have here, just give me a second to erase this and write it down again. ठीक है, तो अगर आपके पास यहाँ पर ये जो है वो positive value है, or this is going to be a negative value. So this is going to give you positive value from the first term, and here negative negative is going to become a positive value for T delta S, right? So when you will be summing all of this, so delta Gibbs value is going to be a positive value. Okay, so it's going to be positive value at all temperatures, no matter it's a high temperature or it's a low temperature. आपकी गिब्स जो है वो हर हालत में पॉजिटिव वैल्यू होगी। अगर गिब्स हर हालत में आपकी पॉजिटिव वैल्यू है तो बेसिकली आपका रिएक्शन क्या है, it's going to be non-feasible, right? So whether you have a high temperature or you have a low temperature, आपकी गिब्स की वैल्यू जो होगी वो पॉजिटिव होगी, जो कि प्रिडिक्ट करेंगे आप, it's going to be a non-spontaneous, non-feasible reaction. So minus T delta S is going to be a positive value. So Gibbs value is again going to be positive value, and it's going to be a positive value at all temperatures. So at all temperatures, no matter it's a high temperature or low temperature, my reaction, the reaction is going to be, the reaction will be non-feasible or non-spontaneous at all temperatures, at all temperatures. All right. So this is how we can make prediction on the basis of the values of the two terms delta H and entropy, and temperature variations we can automatically, we can make that is on normally given in the question.